Klaus-Peter Schmidt, Mauser Packaging Solutions, Head of R&D, Sustainability Management, talking about maximizing impact to minimize footprint, cascading reuse and recycling in industrial packaging.
Hello, everybody. I'm not 100% sure if you can hear me. So, okay. So sorry for that, but it's still, even after 3 years of experience with all these online tools, it's still quite a little strange to participate in hybrid conferences like this. And yeah, but we are adapting, and I'm happy to be here. As much as I would have preferred to be in person with you in South Africa, I've never been to this country, but from the colleagues, I understand it's really a beautiful country. And yeah, unfortunately, it was not possible to be with you in person these days. Nevertheless, thanks for the opportunity to share a little the experience that we made on the reuse and recycling, or the cascading of reuse and recycling in a quite specific industry segment, and that is industrial packaging. So, and I think it's always important if we talk about sustainability or circular economy in specific, especially when it comes to plastic, we always need to also reflect what is the specific applications that we are looking at, because especially with plastics, there's so much flexibility and so many different variation of applications that we can only look at the specific case. So therefore, a short introduction in what we are doing, because not everybody of you might know Mauser Packaging Solutions. So basically, we are a global company with 11,000 employees. I don't want to run through all of the figures you see on the left side, but we are operating in 20 countries, our business on 5 continents. And basically what we are doing is rigid industrial packaging. We do a lot of smaller packaging in the US, but the presentation I want to do today, or the experience I want to share today, is basically about large size packaging. So what we call drums, that is basically everything above 120 liter. We do this in different materials. So we do them in fiber, we do them as metal drums, we do also the plastic drums. In addition, composite IBC, where you basically have a metal cage on the outside and you have an inner bottle that you can exchange for reuse. And what is specific about Mauser or our company is also that we are not only doing the packaging, which for sure is our core business, but we are also, since a long time, are engaged in doing our own blow molding machinery to do the drums and the IBCs. We also operate return systems for our packaging. We operate reconditioning services so that you can reuse the packaging itself. And just lately, we also enlarged our business into recycling activities around the materials that we are getting back. On the right side, you see a little the revenue split. I think why I put these charts on here is basically what I wanted to say is, as a company, we are not only doing plastics, but we are also operating other materials. And I think that is always a discussion, what is the preferred material when it comes to circularity and also to carbon emission and environmental footprint. So we have experience with multiple materials. We are still engaged in plastics also because we believe in the benefits of this material. And what is also important, I think, when we talk about circular use is always the end market. It's we as a packaging manufacturer, we cannot influence the world. It's always about collaboration with the supply chain. And we have to be aware that we are serving with our packaging really a huge variety of end markets. And the need or the performance that is needed for food packaging is completely different to something that is used for road paint, even if it looks the same like an IBC or a drum. Stuck a little, so okay. one step back, if we look at sustainable industrial packaging, it's always basically, even if we have multiple discussion and political discussions around circularity are increasing almost day by day, I think it's always important to remind ourselves also on the basic principles, which to my opinion didn't change too much. So sustainable packaging, first of all, has to be fit for purpose or effective. So whenever we produce a packaging, a drum that is filled with nitric acid and it's leaking, then it's not fulfilling its purpose, and the impact is much higher than saving anything on materials or carbon emission. Nevertheless, we want to do less with or more with less. So we want to do it as efficient as possible. We wanted to do it with safe materials, which I think was much easier in the past. I think the current discussions, especially around plastics and additives, that is sometimes a little confusing or challenging to really meet all of these demands. And in the end, sustainable packaging has to be run in circles. And it does not have to be, in our opinion, the classical closed loop circle. And we always should also look at open loop circles. The second important principle I think we always should remind ourselves is the hierarchy of resource efficiency. So whenever we can take material out, it has a higher impact than reusing a product. The reuse of a product, as seen before, has significant impact, and that is often preferable compared to recycling of the materials, recovery, and only if not needed anymore or really not it can be reused, it should be disposed. Nevertheless, I think especially for plastic, and if we look at plastic waste and the whole discussion, I still believe that a responsible disposal of a packaging is much better than having packaging somewhere in the environment. So what is a business model? Basically, we have developed into from being a purely linear manufacturer of packaging about 20 years ago. I think in the beginning of the century, we started engaging into the reconditioning of our packaging. That is basically then the inner circle you see here. Packaging or the raw material is converted at the manufacturing site. It goes to the filler, is filled, and basically via the emptier, it's returned to the reconditioner. So we clean our packaging. We call it reconditioning with industrial packaging. And the second loop that we do is then the materials that are coming in and that can no longer be used for reuse. They are separated and either they are disposed where we don't have any recycling capabilities, or we send them to our recycling operations where especially the plastics is then recycled and transferred to the manufacturing sites again. So with this kind of business model and cascading, I think the most important that we needed to develop to apply this system, and especially if we talk about large bulk containers like an IBC or a drum, you have to be aware it's international transport and logistics, and you need to have an international network of sites and locations where you recollect this kind of packaging. And that is basically what we have established meanwhile. So it's around 150 locations that are around the world, for sure, the majority in the US and in Europe, but also here in South Africa, you see there are 3 locations that are basically open for recollection of IBCs and tight-head drums, plastic tight-head drums. And that is really important to understand with the whole reuse model and also the recycling. It's all about the inbound stream. So we can only reuse and recycle what we get in again. And that sometimes, in my opinion, is forgotten in the recent political discussions. That needs to be taken care of. So what can we do with the inbound stream? As shown 2 slides before, our preferred option is to reuse packaging. So clean the packaging itself, maybe exchange certain parts for especially here bottles of the IBC, so that basically whatever you fill in is in contact with a virgin bottle, but we still can reuse the outer cage, the pellet, and it has quite significant impact on the environmental performance. So that is a preferred option. Nevertheless, whenever we have materials that can no longer be reused, we recycle the plastics, and the recycled plastics, as said, is used for either production of components or drums. With this setup, we are able to basically offer a wide range of portfolio, not only on sizes and materials, but also different ways or application performance levels on cleanliness. And so it starts with closed loop laundry service, where basically people get the packaging that they used, it's cleaned, and then it's sent back to them. You have open wash circles. You can take out certain parts with the composite IBC rebottle, and we can use the recycled materials in multiple applications in multi-layer technology. So you can do simple monolayer, but the most advanced is doing them in multi-layer technology. But, and I want to emphasize this, there's still a strong need also for virgin packaging at this moment. So if we look a little at the recycling approach that we are able to implement in this quite specific industry segment, I think it comes with certain advantages because we have more or less everything in our own hands. So we do the collection. We also do the sorting in-house, and that especially with our products is quite important because, yeah, sometimes there are nasty chemicals in these drums and IBCs, which basically you have to sort out that they don't end up in the recycling stream. And that is only possible if you get a hand on the packaging itself. Once it's regrinded materials, you are no longer able to track the history. So we basically make use of the inbound grading of our reconditioning activities. So we identify the packaging itself before, and we sort it before we start a washing process of the material and the repalletizing of the material to use it again in the packaging. So it's a quite specific system that we have in place, and that is also addressing the needs that we have on the virgin materials. Because also here we have to be aware, we are talking about polyolefins, HDPE mainly, 90%, 10% polypropylene, but it's quite specific HDPE for these large containers. So it's high melt flow materials with an MFI of 2 to 6, and that you don't find in typical household packaging or the typical waste streams that people often think of. So there's a certain benefit that we have our own inbound stream, and we basically have simplified specifications in place that address that. So we use the material for injection molded parts. There you have a little wider specification, and we use it in the blow molded containers that are then in contact with the filling good again. And here there's a specific requirement, especially for dangerous goods packaging, that you have to fulfill a certain ISO standard that is summarizing the needs on collection and quality checks that you have in the for this kind of material. So a little background or a little more details on this regulative context or this regulatory context that that is needed to be considered. And I think that is also important to, at least that is often forgotten in my opinion, is we are operating our business and plastics business in an existing regulatory environment. And the environmental regulation comes on top. Nevertheless, you sometimes get the impression that people forget that there's existing regulation, and there's also, especially when it comes to dangerous goods, there's international regulation that basically tells you what you need to do to produce a packaging like this for this kind of products. And yeah, if you look at the details, it's sometimes the case that PCR and recycled plastics, even today, is not even allowed for the use in this kind of products. So you basically have to start with changing international regulations to at least have the possibility to do this kind of packaging from recycled content. So it's all about this ISO standard in our business. And here it's clearly that are coming out of industrial packaging. Other PCR materials are not allowed. You have to have defined batch testing. So we are always talking about 25 tons of batch of material. We also have to test the products that are produced from this. So there's a lot of requirements that are coming with the use of recycled materials. And the industry is more or less advocating to really simplify also the regulations, because some of these are from the 1990s. So the most recent important steps, in our opinion, into the future of more use of PCR have been in the 1920 or in 2020. Basically, there was a change in the regulation that we at least are allowed to use PCR also for the production of the bottles of these inner containers. That is today common practice. And the most recent change in regulation by end of last year was basically that also, meanwhile, people are widening a little the specification of the inbound waste streams for this kind of applications. So the takeaway is we need to consider and we need to change existing regulation on top of the upcoming environmental regulations. When we go back a little to the technical details, or what have we installed on our recycled materials that we do. So we have operate 5 recycling locations at this moment around the world, and they are basically all operating in the same way. So we have a special sorting system, as I already explained. It's the incoming goods are basically at our reconditioning sites, that they are coming in as full containers. They are sorted according to the criteria mentioned in the ISO norm. Once that is done, we have clear inbound stream and defined inbound stream. There is a grind and wash process that is quite typical for any kind of plastics recycling. So there's not too much specific about that. What is a little different or specific is then the granulation or the repelletizing. Again, it's an extruder that is not special, but as we operate this high melt flow materials, it has to be a quite specific extruder, and therefore sure the experience that we have in the conversion and doing our own machinery and blow molding machinery with the same kind of virgin material clearly help to establish this kind of technology. Because again, your typically recycler is not used to handle this low melt flow materials. What can we do out of the materials that we are generating? It's basically, we call that our infinity series of packaging. We started with monolayer packaging, where basically you can incorporate anything up to 98%, except 2% maybe for the colorant that you want to integrate. But the market acceptance of this kind of packaging is also limited. We meanwhile operate also in all of the regions multi-layer equipment. Recently we have installed something in South Africa also, a 3-layer machine, where basically you then have a setup where you on the inside have virgin material, so that the customers are no longer, or the users are not too much afraid of any cross-contamination that might happen, and you have the recycled content on the outside. Or the most advanced is the 3-layer technology. It's old polyethylene, so we are not talking about barrier layer or non-recyclable multi-layer structure. So we are talking about polyethylene multi-layer here. And there you have on the inside and on the outside your virgin material, and that gives you also the best performance. What I think is important to look at is what is the maximum PCR content you can put into a blow molded container that has a 2-layer or a 3-layer structure, which is clearly the most accepted in the market. And if you look at this, with the blow molding, you always have the flash on the bottom and on the top, and you have to take care of the material being incorporated again. So, and that limits the amount of PCR you can put into this material. So it's not one by one the layers setup, it's lower. And if you look, for example, at the 50%, that is 51 is the maximum we can do with this layer setup. And 51, if you look at targets, recycling targets, like in the plastic bracket, packaging waste directive in Europe for 2040, the target is 50%. So that is a target that is, if you look at the technical details, almost impossible to achieve from our perspective. So if you further look, and that is a little the slide on the European legislation, and I think that is or not the existing, but what is on the horizon at this moment. And I think there was also this morning already a presentation, or at least a short outlook, that there's currently some discussion on the revised plastic packaging waste. It's no longer directive, but regulation. So there's a clear benefit with this approach, and that means it will be a European regulation, so it's binding for every member company, and that clearly is a benefit to existing systems where every country seems to address the same problem with different regulation. That is non-favorable for our industry at this moment. For example, you have a situation in UK and Spain where they apply different tax models to the use of virgin plastics, and customers are more or less requesting by end user market a different setup of packaging. So that is quite difficult to be handled. So we are clearly in favor of having a unified regulation. In our opinion, serving a global market, it would be better to even have global specifications and approaches on that kind of topics. But if we look a little at the targets that are being put on the table, it's really a question, how realistic are these targets? We are all for ambitious targets, but we also believe they have to be achievable to a certain degree. And if we talk about a time frame of 2030 and 35% recycled content mandatory for any non-sensitive product and 10% for sensitive products, so, and that is an average, that is really ambitious, or maybe a little over ambitious. Same with the reuse targets. I think we are in the business, we see the benefits, but the targets that are currently under discussions are really more than difficult to be achieved. And what is, in our opinion, often not reflected is really the specifics of the environmental benefit. I think the speaker before me did some quite nice LCA studies or presented on when is a reuse system really providing certain advantage, and all of this kind of input and scientific based foundation at this moment in the regulation is at least sometimes not really well reflected, in my opinion. So it's clearly what we see. We are already engaged in reuse and recycling. And I think the figures that I wanted to share here in this slide, basically they speak for themselves. So on the left side, you have global figures, and that is all annual. So that is from the 2021. The 2022 figures were not available per today, but in 2021, think basically with the system I showed, it's 10 million containers that have been taken back from the market, generated 43,000 tons of plastic material. We converted a little less, so basically 35,000. But with doing the reconditioning and the recycling in parallel or in a cascadic use, we more plastics and roughly 100,000 tons of metal virgin materials that we don't need to use to produce our packaging. On the right side, the South African figures. So it's a little less for sure, not only because of being local, but also we just recently introduced, for example, the 3-layer technology on the drums. So PCR converted is not the case in 2021. But also on the reconditioned units and what we took back from the market. So it's basically 750 tons of material have been recovered, and in the combination of reconditioning and recycling, it's the figures that you see here below. So there is already systems in place that have quite significant impact on material saving. And that more or less brings me already to the summary of my presentation, where I think it's always important to remind that we can only do this challenge together. So I think circular economy is much more about collaboration along the supply chain than the linear economy. At this moment, we see when it comes to plastic and plastic packaging, it's really consumer packaging driving the political initiatives. And it's often forgotten that there's other kind of packaging. And that is one of our greatest concerns at this moment, that we basically get tailor-made regulation having consumer packaging only in mind. And we are always fighting to make the people aware that there's also other type of packaging that maybe need also other regulations or other target settings. Thinking about application, I think all of us do packaging not because we like it so much, but it serves a certain function. And that is key. And PCR usage makes only sense, or reuse of this packaging makes only sense if we still are able to fill the purpose it's intended to do. From a perspective, especially for the large packaging, the global perspective, in our opinion, is always important because it's global logistics that we talk about. So South African regulation, there's a lot of import and export. So local legislation is always difficult. And we need to consider or remind ourselves that changing regulations, especially if we talk about international, that takes time. So it takes about 5 to, let's say, 8 years to get changes in this UN model regulations for dangerous goods packaging. So all of this needs to be somehow reflected in whatever regulation we approach and what we are confronted with. And the last bullet point here in that summary is basically, and for me also the question or the challenge is at this moment, the focus is clearly on material and waste and how to avoid it. But in the end, we have in parallel a different challenge, and that is the carbon reduction that we need to address. And it's sometimes a little questionable if both regulative initiatives are going in the same direction. And I think it's quite clear for especially plastics, it's there is some benefit, and that at this moment, with all the discussions about plastic waste and also the responsible use of plastic, and that is for me out of discussion. So there's no need to have plastics in the ocean, and we need to address it. But we also should not forget that plastic is a material that, when it comes to carbon emission, has significant potential for weight reduction. And it also has significant potential when it comes to the carbon footprint itself. So here's an example on a plastic drum on the left side. So that is the typical weight of a 220-liter drum. A steel drum is basically double in weight. And also the carbon footprint of a kilogram of steel is higher than the one of plastics. And here we are not talking about recycled plastics, that is even below. So I think that is basically now really the end of my presentation, where I wanted to at least give a little food for thought or advocate a little for plastic in general as a material, I would say, that has currently certain issues because it has not been handled responsible maybe as it could be in the past. But it clearly also has high potential for the future difficulties which we will have to face. So thanks for your attention, and